Right, we're back. So we talked about networking today. Then we saw how to implement a local development workflow, and now we are going to go back to networking again. So the plan is to talk about the container network model. So let's see what is this about. Then we will talk about service discovery and finally about Compose. So we're going to talk about the container network model. So what is that exactly? The container network model is a set of concepts that have been introduced by Docker when manipulating groups of containers. So because in the beginning, we had just one container, two containers, three containers. We expose ports just like we did here. And the example I gave you with the Namer application, it looks very nice. And oh yes, you can have 5 copies running at the same time. Now, in the real world, you don't have just one container for the application. You're going to have multiple containers. So if you want to deploy multiple copies of your application, that means multiple groups of containers. For instance, if we think about the Wordsmith app for which we've wrote Docker files earlier today, we have web words DB. So if I want to run multiple copies of that app, now I'm thinking about web words DB multiple times. So that's what we want to solve with that container network model. Okay, so now concretely, how does that work? Well, the idea is that Docker gives us multiple networks. And at first you can think of that, just like the Wi-Fi networks, if you use your phone or your computer and you go to the wireless like Wi-Fi networks, you can see a list of networks and you decide which network you connect to. So it's a little bit like that. Okay, the technology behind it, of course, is completely different because this is just a bunch of containers on the machine. So there is no Wi-Fi, there is no wireless, there is no access point and all that stuff. But conceptually, you can see a bunch of networks and you can decide, I want this container to be connected to that network. So we can list the networks like this, Docker network ls. And on a brand new Docker install, you will have these 3 networks. So the first one, Bridge, that's the default network. So that's the one which is used if we don't do anything special. Host network and non-network, okay, these ones, I'm actually going to ignore them for now because they are a little bit more complex. But we can create networks for our applications. So for instance, I can do Docker network create dev and also prod. And so now if I Docker network ls, you can see that I have networks named dev and prod. And you can see that they use also driver, bridge, and scope local. Okay, what does that mean? Scope local, it means that this is a local network that only exists on that machine. You can also have global networks. So you can have multiple Docker machines connected together. And when you create one network on one machine, then it will also exist on the other and the containers will be able to communicate together. But in practice, you will not be using that except if you use Swarm. So I'm not going to talk about scope, for what we do this week. Everything is going to be scope local. We don't need to worry about it. The driver is also always going to be bridge. And if you wonder what this bridge thing is about, I'm going to use a few network words here. So if if networking is not your thing, don't worry too much about that. But the bridge here refers to a Linux bridge, which is basically a virtual switch, like a switch, like an Ethernet switch like this, that you can use to connect multiple computers. Basically, what we have with Docker is something like this, except instead of being a physical one, it's a virtual one in the computer, and we use it to connect the containers together. So when we have these networks, it's as if I had these virtual switches. Well, they're called bridges, but technically bridge, switch, same thing. So we have these bridges or these switches, and when we start a container, we plug it to this network or that network, basically. Okay. Just in case some of you have a strong background in networking, we can also compare that to VLANs, if that's something you know about. So you can have multiple VLANs and you can decide on which VLAN you connect this container or that container. All right, okay, so now we have multiple networks. What can we do with that? First, before I dive into all these examples, I want to give you a little disclaimer. I'm going to show you a bunch of commands here with Docker Network. And I just want to tell you that, in fact, you will very rarely use these commands. So once again, you could wonder, hey, why are you showing us these commands if we will not be using them? Well, you are going to use these concepts, but very often, most often times, you will use them through Compose, which I will show you a little bit after. So here, I'm going to basically show you how these networks work by running the commands like manually, one by one. Oh, let's create a network. Let's connect the container to the network. Let's see what happens. But in practice, you will see that we will have tools to automatically create the networks and connect things together. The reason why I'm showing you these commands are two reasons. First, so that we can understand what's going on. And second reason, sometimes you might have to debug and troubleshoot things, and then it's great to know that these commands exist. Okay, so we created a few networks. Now, what can we do? I can, let's see. So on top, that's going to be dev. So I'm going to run that. I'm going to add --net to indicate to which network I connect. So --net dev -ti, and I'm going to use image Alpine. I don't think I talked about Alpine yet. Alpine, this is a Linux distribution, which before containers was very confidential, maybe it's not the right word, but it was not very famous before containers. But with containers, it changed everything. Now everybody, well, maybe not everyone, but lots of people using containers are using Alpine. Why? It's a distro which is optimized for disk space, like disk usage and security. And before, the disk usage aspect was not very important. Like imagine somebody tells you, hey, I have my whole Linux system here in only 200 megabytes. And yours is way bigger. Look, it's 2 gigabytes. I'm like, okay, cool story, but I don't care because my disk is 100 gigs or 1 terabyte or whatever. So your tiny Linux distro here, what's the point? Now with containers, it's a completely different story because with containers, some people will have an image which is maybe 100 megs. And with Alpine, let's look at the size of the Alpine image. It's 7 megs. This is very small. And if we compare with BusyBox, BusyBox is also very small, but BusyBox is not really extensible. You have BusyBox, and that's it. You cannot add new things. You can, but it's very complicated. So usually you use BusyBox the way it is, and that's it. Alpine, on the other hand, if you want, you can install packages, and you have tens of thousands of packages, just like on Ubuntu and Debian and Fedora, etc. So Alpine is a distribution that has the advantages of both the small ones like BusyBox, so it's small, doesn't use a lot of disk space, and the advantages of the big distributions in terms of number of packages, etc. So Alpine became really popular with containers because as we started to use containers more and more, we ended up spending more and more time waiting for images to pull. And so, you know, when you look at your image like slowly downloading and the image is like 300 megs, and suddenly someone tells you, hey, I have an image which is only 10 megs, now that's interesting because it means I will wait only 10 seconds instead of 3 minutes to download that image. All right, so I'm going to use Alpine more and more during the rest of the week, just to give you an idea of what we have on Alpine. And as a first example, you know, here I'm going to docker run --net prod -ti Ubuntu. And for instance, I want to do something very simple. I want to look at the IP address of the container, and I'm going to use an old-fashioned Linux command, ifconfig. That's for interface config. And on Ubuntu, we don't have ifconfig. But on Alpine, we have it, which is a very interesting paradox because the whole point of Alpine is that it's smaller. It's smaller, but it has more tools than Ubuntu. Like, what's going on? Why? Well, precisely because it's more efficient, let's say, to simplify things a little bit, precisely because it's more efficient, it can afford to add a bunch of tools that we don't have on Ubuntu or Fedora or etc. out of the box. Of course, if I want ifconfig of Ubuntu on Ubuntu, excuse me, I can add it, I can install it, but it's going to be an additional package. So it's a very interesting thing that happened here because you know, like Ubuntu and same thing for CentOS and Fedora, etc., is bigger. And it's still missing some of these packages. So why are these packages missing? Well, because the folks working on the Ubuntu images try to reduce the size of these images, try to optimize these images as much as possible. And so they removed a lot of things in these images to try to save space. So the result is an image that is smaller, but it's still relatively big, like 77 megabytes, but so it's 10 times bigger than Alpine, but it doesn't have some of the tools that Alpine has. Okay, so I'm going to start Alpine in both cases, and what I want to look at is, there we go, like this. I want to look at the IP addresses of the containers. And we can see, so here it's the dev, it's on the dev network, and here it's on the prod network. And you can see that on the dev network, the IP address is 172.18 something, and on the prod network, it's 172.19 something. The reason why I'm showing this is just to highlight that on each Docker network, we are going to have a different subnet, a different range of IP addresses. Okay, small detail. What else can we do? Well, now I'm going to start a couple of Nginx containers. So Docker run in the background, --net dev Nginx, and --net prod Nginx. And now I would like to get the IP addresses of these containers. So docker inspect C5F and also 893 grep. Ooh, poo, 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 poo. Okay. grep IP address. Okay. So they are 172.18.03 and 172.19.03. All right. So I come back. Sorry, not here. Here. So here I can do ping 172.18.03. Okay, that works. So here I am in the dev network and I am pinging the dev Nginx. And you see, yep, it works. Great. I can ping it. I can use curl to connect to it like this. Okay, that works. Great. And now if I go on the lower terminal, I'm on the prod network. And on the prod network, my Nginx container is 172.19.03. I can ping it fine. I can curl it. Awesome. However, now if I try to cross the streams, let's see what happens. So here I try to ping 19.03. That doesn't work. Although, so what this is showing is that when you are in the network, you can only access the containers that are in that network. So the different Docker networks are isolated from each other. Okay, interesting. So that means that if I think about my Wordsmith app, with web words DB, if I create multiple networks and in each network I put a copy of the app, each copy is going to be isolated from the others. Cool. Now there is another really interesting feature with networks, and that's related to service discovery. So what is service discovery about? Well, imagine some completely imaginary code, right? And at some point I need to connect to a database. So I might have something like a DB connection equal, Postgres connect. And here I typically put the IP address of my Postgres database, maybe something like this. And maybe I have a login and password or whatever. Now, of course, if you have a little bit of experience writing code, you probably know that it's not a good idea to hard code that kind of information. You hard code the IP address of the database. We might do something like this. Here we would say like config.db address or whatever. Or maybe we would use an environment variable. So we would have something like db address, and then we would put something like db address equal, environment, db address or whatever. So this is what service discovery is about. It's how do I find the address of that other service? How do I discover the address of the service? So how do I discover the service that I need to connect to? And in different languages and different frameworks, we've done a ton of things in that sense. If you work with Rails, for instance, there is this notion of environment. And when you switch environment, it's going to switch a bunch of variables with databases, not only the address, but also login, password, etc. So what do containers give us here? Well, they give us network aliases. So the idea is that in my code, I could write something like this: db connection equal pg connect. And here I'm going to put just db, like this. And there's going to be a little bit of magic that will transform that name, like db, into the address of the container running the database. And for that to work, all I will need to do is docker run, so --net, my little network, and I would do --net alias db my database image, something like this. So I would basically tell Docker, run this image, connect the container to that network, and give it that network alias. So now, when you are in that network and you resolve that name, you get the IP address of this container. Now, technically, when I say, oh, there is a little bit of magic to blah, 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 when I say a little bit of magic, the reality is that there is a dynamic DNS server embedded in the Docker engine to manage that. DNS, really quick reminder, DNS is the thing that transforms names into addresses. So for instance, if I do ping kubernetes.io, I get this IP address here. That's DNS doing this mapping, or ping nx.fr, same thing, mapping name to IP address. That's DNS. So we have a DNS server in Docker so that when a container will try to connect to DB, that DNS server is going to give us the corresponding IP address. Demo, I'm going to Docker run --net dev --net alias, let's say API. And I'm going to start a good old Nginx. Okay. Now I go back here and I try ping API. So that works. Now if I try ping API here, it doesn't work because the network alias that I created, it's only in network dev. I created network alias API, but only in network dev. So if I'm in network prod, there is no API. Now, if I start another one in --net prod, and now I come back here and I try ping API, it works. And if you look closely, you can see that the number here are different. So you can see that it's a different container. And that's, it may or may not seem like much, but that's actually extremely interesting, extremely powerful, because it means that when you try to connect to API or DB or whatever in a network, it's going to be local to that network. So if I go back to my Wordsmith app of this morning, well, earlier today, when I have web words DB, I can have web words DB in a first network, web words DB in a second network, web words DB in a third network. And so each network, it's going to have like its own little universe, if you will, independent from the other ones. It's a local name, the same way that if we are in a room somewhere and somebody says open the window, we understand that they mean the window in this room, not the window in the next room or in the next house or whatever. So that's the same idea here. When I talk about API or DB or whatever, that's API, DB, or whatever in this network. Okay. So here I used ping, but I can also connect with curl or anything I want. It's going to work the same way. And so that's that's part of the container network model, like this concept of having a network alias that maps to a container. Now, what's really interesting, I think I already said it was really interesting. So what's even more interesting is that this concept will apply also to Kubernetes. When if you continue to Kubernetes, we will have a very similar mechanism with names corresponding to addresses. The implementation will be different because instead of having a name corresponding directly to a container, you will have a name corresponding to a cluster IP, which itself is a kind of load balancer. So you have extra intermediary steps, but at the end of the day, the code will work exactly the same way, and that's very, very interesting. So that means, just to give you an example, that means that you can get some code that runs on Docker, and then you can take that code and run it on a Kubernetes cluster without changing a single line of code. I can even give you like a concrete example. There is an application, like a demo app that I wrote a while ago. It was 2015. I wrote that app before knowing Kubernetes. I knew nothing of Kubernetes at that point. And so I wrote that app for Docker environments. So I write that app for Docker, and then I got that running on Docker. That app, I still use it today with Kubernetes without changing a single line of code. So that means that I was able to write code that works on Kubernetes without knowing Kubernetes, and I didn't need to change that code. I don't know if you see what I mean, but what I mean is that the container images that I've built back in 2015 at the point where I didn't know anything about Kubernetes, these images work today on Kubernetes clusters just because they used this same service discovery mechanism based on DNS. I would like to give us a few diagrams, a few examples of how things really work, like how it's implemented, to understand how it works behind the scenes or under the hood, or whatever metaphor you prefer. So when we run Docker on Linux, it's going to look like this. So you have your Linux machine, and you have your containers running on a network. And then you have the Linux kernel that kind of it's going to route and bridge packets between the containers, but also between the containers and the outside world. So that's what we do on these environments here. Now, if we have multiple networks, so what I was just demoing earlier, now you have these multiple networks, each isolated from the other ones. And what's interesting is that if you are directly on the Linux machine, you can connect to all these containers. So that's interesting, because as a developer, when I'm here on my Linux environment, if I want to connect to a container, I can do it directly. Now, and that's the part that's really interesting, I think, to understand the difference between Windows, Mac, and Linux environments. Remember what I said yesterday in the beginning? I was saying that Docker only runs on Linux. And so when you run it on Windows or on a Mac, it actually runs in a small VM. So what that means is that if I'm on Windows or on a Mac, the containers are in this VM, and I am outside of the VM because I'm on my Mac or Windows machine. I am not inside the VM. Of course, I have access to the VM because it's running right there, but I am not inside that VM, which means that I cannot connect directly to these containers. From a network perspective, when I'm on Mac or Windows, it's as if I were outside of my Docker environment in a way. So it's a small and subtle difference, but that means that if I get the IP address of a container, like this, here I can connect to that container directly because I'm on Linux. But if I were on a Mac or on Windows, if I do Docker inspect and I get the IP address and then I do curl, it would tell me like some network error because I cannot connect directly to that. On a Mac or on a Windows machine, if I want to connect to a container, I need to expose the container to publish the container. Small difference, and I mean, for me, who works a lot with containers and who has been using Linux for a while, that's I'm like, well, that's an advantage. If you work on Linux, it makes your life so much easier because you can connect to your containers directly. So when you do load testing and like security testing and many scenarios, it just makes your life easier. And if you're on a Mac or Windows machine, you have to remember that and remember that you need to expose these ports when necessary. All right, one little thing to put things in context between CNM and CNI. So CNM is the Container Network Model of Docker, and CNI is the Container Network Interface, which is a different mechanism that you will find on Kubernetes. So it's kind of interesting to see, okay, what's the difference between, let's say, to simplify a little bit, between Docker networking and Kubernetes networking? Well, unfortunately, the two are very different. Why and how? So the concept of CNM is that you have these networks, and these networks are independent from each other. Each network is isolated, so that's why you might have heard sometimes in Docker presentations, they say, oh, Docker is secure by default. And it's true. It's not just like marketing bullshit, but there are lots of design and technical decisions in Docker that make it intrinsically more secure. Like the fact that these networks are separated from each other, great. In Kubernetes, what's the difference? In Kubernetes, you have one big network and all the containers are on the same network. Small detail, in Kubernetes, we don't call them containers, we call them pods, but for now, we can say same thing. So by default, on Kubernetes, everything can communicate with everything else. So arguably, it's less secure, but if you want, you can add isolation with a mechanism called network policies. Now, on the other way around, if you are on Docker and you want communication between networks, that's where you need to do extra steps. So you can see the idea on Docker, we have isolation by default, and you need to do extra stuff if you want to connect things together. On Kubernetes, it's the other way around. On Kubernetes, everything can communicate, and if you want to isolate, you need to take extra steps. And that's just one little example. There are other scenarios, like other things that are going to be different between the two models, but I think this is a pretty good example. Now, at the end of the day, it doesn't really make a big difference. You can, if you want isolation on Kubernetes, you can have it. If you want connection with Docker, you can also have it. It's kind of unfortunate that we have two very different network models, but well, that's the way it is. Okay, so we created networks, we put containers on networks, we talked about service discovery, and I'm going to show you a little example, like service discovery in practice. So I'm going to go back to my little web agency where I'm working, and like, okay, I'm going to ask my manager, what do you need me to do now? Well, now we need you to work on this application. It's called Training Wheels, and it's on JPay Training Wheels. There we go. Whoops. I probably, yeah, I misspelled it. My bad. Training Wheels. Okay, so we need you to work on this application. I'm like, all right, let's try this. So git clone this repo and go to the Training Wheels directory. I have a Docker Compose YAML file. That's interesting, and that's probably related to Docker, but we haven't talked about this yet. So let's go and see what else do we have. We have a www directory, and in there we have a Docker file. Okay, great. Let's go there. And since we have a Docker file, we're going to build it. Docker build.-t training wheels. Training wheels, you know, that's the name of the little wheels that you put on the back of the bike. You know, when you learn to ride a bike, usually as a kid, to avoid falling from the bike, you have these little wheels on the back. These are called training wheels. Okay, so we built training wheels. Now I'm going to do. Okay, it's exposing something, installing dependency. Okay, great. So I can docker run -d -p training wheels. Great. Now we can connect to this application 49164. Okay, let's connect 49164. And we get a big error. It's a, well, just internal error. What could be going on? Well, I'm going to use Docker logs to see the logs of the container. Docker log C837. And we have traceback, blah, blah, blah. What's going on? We have this error, that error, etc., etc. And at the end, it says name does not resolve. And if I go at the very end, error connecting to Redis colon 6379, name does not resolve. What's going on here? Let's look at the code, because the code is really short, so it's you know, that's it. There's like 43 lines of code. And in the code, we have something that tries to connect to Redis. Remember my example with like db equal pg connect, etc. This is exactly what's going on here. We are trying to connect to Redis. So Redis is a key value store, which is used as a small in-memory database in that demo app. So we try to connect to a container that should be called Redis. Interesting. Let's try to run that in the dev network. So leave that, docker run --net dev. Okay, great. Which port number? 49165. All right, let's go to 49165. We get the same error. Now, since this application is trying to connect to a Redis database with the name Redis, I'm going to give it to the application. I'm going to do docker run -d --net dev --net alias Redis. So I'm starting a container with the Redis image, and I'm giving it the network alias Redis. And now here I'm going to hit reload, and whoops, sorry, I'm still on 49164. I'm supposed to go on 49165, and now that works. Okay, that was not the best demo ever, so I'm going to do it again on the prod network this time. Okay, so I want to do that in prod, and so that we can make the difference, I'm going to edit the template here. Let's see, where is the training wheels? Production. All right, that way we will know which is which. Okay, now I docker build, docker run, docker run, there we go, training wheels prod, Okay, what's the port number for that one? 49166. There we go. So for now, we have an error because I have a Redis container in the dev network, but I don't have one in the prod network. So in the dev network, this is the dev version, it works. Each time I hit this is just something counting the number of requests. So it's I will explain to you just after why I did this. So now in the prod network, it doesn't work yet because I don't have a Redis container. So I'm going to give it a Redis container. So --net prod --net alias Redis. And now I reload and it works. And you can see the difference. This one says production. And each time I hit reload, you can see that the number of requests increases. And you can see that we have separation between the two. So on the left, that's the dev version. On the right, that's the prod version. And what's interesting is that this is a full stack, so to speak. Okay, it's a kind of a small stack because it's 2 containers, but it's still more complicated than just one container. Now, instead of just having one container living on its own, I have 2 containers in the dev stack, 2 containers in the prod stack, and it's the same stack. There is like a front end and there is a Redis database in dev and front end Redis database in prod. So now we could take the example that we did earlier with the with Namer, but we could do that on a more complex application. Here I just have 2 containers, but you could have 5, 10, 20 containers. It would be exactly the same thing. Okay. So that's that's what the container network model gives us, like this ability to have these networks. These networks are isolated from each other, and we can have these network aliases that we can then use for service discovery. There are lots of extra details here, but just like I was telling you a little bit earlier, this week I want to teach you just like well, maybe not the bare minimum because it would sound a little bit minimizing, but I want to teach you just what we need for Docker in development environments, because we know that in production, often we're going to use an orchestrator like Kubernetes, so we don't need to learn all the advanced Docker networking things. But if you're curious, there are like many other details in the slides here. All right. One thing, I'm just mentioning this just in case, but if you want, you can also connect and disconnect containers to networks dynamically. There are not many use cases for that, but just in case, if you're wondering, yes, it's possible. All right. So I was telling you earlier that I was showing you these commands, you like Docker network create and Docker run --net, but I was also telling you, don't worry, typically we will not have to use these commands because there is an amazing tool called Compose that will do that for us. And that's the tool that I'm going to show you next.